Let's continue with our inverse trig review. So, example 4, use a calculator to evaluate. This is just as simple as it sounds. Type it into your calculator. Just remember that arc sign is the same as this. They mean the same thing. And this button should be second sign on your calculator. Make sure your calculator is in radians, and then you should be able to type that in and get 0.304. That's it. Just type it in. Same thing with tan. You'll find this inverse tan function or arc tan function by doing second tan, and then you should get negative 1.190. That's it. Ta-da! Okay, simplify without using a calculator. On these ones, it goes pretty fast and easy because remember that sine and arc sign cancel each other out. They're inverses. So our answer, root 3 over 2. Ta-da! Tan and arc tan cancel out. Our answer, 3. Ta-da! Arc cosine and cosine cancel out. Our answer, 5/3. Ta-da! Arc sine and sine cancel out. Oh, dang it. Our answer is not 11 pi 6, and here's why. Sine is between negative pi halves and pi halves. 11 pi 6 is not between negative pi halves and pi halves. So, if we look right here, there's 11 pi 6. That would be negative pi 6 as well. So that's actually our answer. And you can double check all of these, that these do lie between the ones we want. Okay. Number 6, solving for x. First off, I need to get rid of that arc sign, so I'm going to take the sine of it so that it will cancel out. But if I take the sine of one side, I have to take the sine of the other side. So I have x squared minus 3 equals sine of pi halves. So I go up here to pi halves and grab my y value, which is 1. Add 3, so I get x squared equals 4. Square root of 4, so I get plus or minus 2. Ta-da! Okay, last 3. So let's do sketch a right triangle, evaluate without a calculator. First, we have arc cosine of 2 over root 5. So something to know first off, we are no longer talking about the unit circle on these ones. We're creating a triangle. So cosine, if you remember, is opposite, adjacent over hypotenuse, or the x value divided by the radius. So I'm going to do something where my x value is 2, make a triangle, and my radius is root 5. Sorry about that. Now, I know that I can use Pythagorean's theorem to find that last side. So 2 squared plus my y value is square root of 5 squared. So 4 plus y squared equals 5. Minus 4. So y squared equals 1. So y equals my plus or minus 1. But this is in the positive direction, so it's going to be positive 1. So now that I've completely filled out my triangle, now I can find tangent of x. Remember, tangent is y over x. So my y value is 1. My x value is 2. Done. Number 8. We know that y equals the arc sine of x. So we're going to do the same thing. We're going to call this x over 1. And we know that our y values is y over r. So I'm going to draw a triangle just like I had before, where my y value is x, which is kind of weird, but bear with me. My radius is 1. I can do Pythagorean's theorem again to find this last side. So a squared equals 1 squared, or 1 minus x squared. Square root of that. So square root of 1 minus x squared is going to be the length of that side. Now I want to find cosine of this. So cosine is x over r. Let's see, did I do that right? Yep. Okay, so my cosine value is square root of 1 minus x squared. My r is 1. But I don't actually really need that. Now, I know that problem was really weird. We did it that way because it's going to help us find the derivative of arcsine. And here's how we do this. We're going to say that y equals arcsine of x. And now we want to find the derivative. Well, it's easier to just get rid of the arcsine altogether, cancel those out. So I have sine of y equals x. Now let's take the derivative. So the derivative of sine is cosine, and this is an implicit differentiation where we then have to do the derivative of sine. And we're taking it with respect to x, so the derivative of x is 1. Now I can divide by cosine of y, divide by cosine of y. So I've got that my derivative is 1 over cosine of y, which we just found out in the last problem. Cosine of y is square root of 1 minus x squared. So that right there is our derivative of arcsine of x, which you can see right there. So here you go. Here's all your derivatives of your inverse trig functions. Yes, they do need to be memorized, and yes, you can apply chain rule to all of them. In the last video for this lesson, we'll go through a couple examples where we go through and practice these new derivative rules.